Hello and welcome. In this video we are going to discuss about structures in C. So what is structure? Structure is a user defined data type. It can be used to group items of possibly different data types into a single type. So where we use structure, when we should use structures, that we are first going to discuss. Structures are basically used to represent entities. So what entity is actually? Entity can be anything existing in this world. For example, bank account is an entity. It will have some attributes like account number, account type, account balance. So it have many attributes. So an entity, if you want to represent it, for that you can use structures. Similarly, if you want to represent a point is another example of entity. If you consider a 2D point, it will have two attributes: x coordinate value, y coordinate value. If the point is 3D point, then the point will have three attributes: x coordinate value, y coordinate value, and z coordinate value. Similarly, if you want to represent time, time is another example of an entity. It will have three attributes: hours, minutes, and seconds. So if you want to represent an entity as a data type, you have to use structure. So how we can use structure, that we are going to discuss in the next slide. So first of all, if you want to group some items, some attributes, then you have to define a structure. How you can define the structure? First you have to use the keyword struct. After that you will use name of the structure. It's called structure tag or structure name. And then within the braces you will write the attributes of the structure. For example, in case of address, the attributes are name of the person, street, city, state, pin code. So you can define those members which are the attributes of the structure inside the braces. So these are called structure members or fields of the structure. At the end of the structure definition, we put a semicolon that indicates the end of the structure. So I repeat, when you define the structure, first you write the keyword struct, then structure name. After that, within the braces, members of the structure, and after the right brace we put the semicolon. So this is how we define the structure. Another example, if you want to define a time type structure, you will write first the keyword struct, then the name. As we discussed earlier, this time we have taken this word time as the name of the structure. Then within the braces, members of the structure. So as we discussed earlier, the time will have three attributes: hours, minutes, and seconds. So I have declared three variables, each of type integer, in the braces of the structure. So these are the members of the structure, and this is the structure tag. And after the right braces, I have put a semicolon to mark the end of the structure. So when you declare the structure, basically the memory is not allocated for the structure members. Memory for the structure is allocated when we declare a variable of type structure. As we discussed in the first slide, that structure is a user defined data type. So the name of the structure can be used as a data type, as you are using the fundamental data type like int, float, double or long to create a variable or declare a variable. Similarly, the structure name can be used to create the structure variable. So there are two ways to declare a structure variable. In this slide, we are going to discuss the first method. If you want to declare a structure, we can put the structure variable name before the semicolon that we put after the right brace. So here in this example, I have defined one structure named point, and in this structure we have two members x and y. So it is a 2D point. This is representing a 2D point, and after the right brace I have written one variable name p1. So this is basically the structure variable p1. So this variable memory will be allocated for this variable p1, and p1 will have all the members of the structure. So because the point have two members x and y, that means p1 will have two members x and y. So I have shown that in this diagram. So this is the memory block that will be allocated for the variable structure variable p1. How many bytes of memory will be allocated for the structure variable? It depends upon the type of the members of the structure, because this structure have two members x and y, and both the members are of type integer. So that means 4 plus 4, 8 bytes will be allocated for the structure variable p1. So this p1 will have two members, one is x. I have shown that on the right hand side. 4 bytes will be allocated for the x and 4 bytes for the y. So p1 will have two members x and y. So how we can use these two members that we discuss in the coming slides. So this is the first member. When you declare the variable, you put the variable name after the right brace. If the number of variables are more, then you can use the comma. For example, if I want to declare 3 variables, then I can declare those 3 variables like this: p1 comma p2 comma p3 semicolon. So that statement will create 3 variables. This is the second way to declare a structure variable. Here we are declaring a structure variable like a normal variable. So for that you will use this statement struct, first the keyword struct, then name of the structure, and after that the variable name. So this is your data type, user defined data type. Point is the name of the data type, and this keyword is basically informing the compiler that this point is a structure type data type. So this statement will create p2 a structure variable, again because this point is having two members x and y as we discussed in the previous slide. So 8 bytes will be allocated for the variable p2, and again the p2 will have two members, one will be the x, other will be the y. So then comes how we can initialize a variable. As we discussed in the case of fundamental data types, if you want to initialize a variable, you have to write the statement like this: int a is equal to 10. So that is the initialization of the integer variable. Similarly, you can initialize a structure variable. Initialization, I just want to remind you, initialization means assigning values to the members of the structure at the time of structure variable declaration. So its initialization is different from assignment. I will explain that in the coming slides as well. So this initialization means, I repeat, assigning values to the members of the structure at the time of structure variable declaration. So we are declaring one structure in this statement, structure variable in fact, P3. This is your structure variable, and we want to initialize both the members x and y of the structure with some values. So for that you will use comma, and then within the braces we will put the values, because this point structure, as we discussed in the previous slide, has two members x and y. So this value 6 will be assigned to the first member x, and the second value will be assigned to the second member of the structure, that is y. So I have shown that in this diagram over here. So here mistakenly I have written over P2 over here, but actually it's P3. So P3 is having two members x and y. The value of x member will get initialized to 6, and that of y will get initialized to 14. Similarly, this is a variable like declaration and initialization. And if you are declaring the variable at with the structure variable declaration, structure declaration, then you can use this kind of statement. Here we have used the variable name after the braces, and after the braces you can write the equal to sign, and then within the braces you can put the values that you want to assign to the respective members. So please note, in this case we are declaring the structure. This bracket basically indicates the end of the structure, and this P3 is a variable of type point, and through these two pair of braces we are assigning the value 10 and 20 to the members of the structure x and y respectively. So this line will declare uh, a structure variable P3 and will assign value 10 to the member x of P3 and 20 to the member y of P3 structure variable. Then comes the designated initialization. So the order of the values should be same as the order of the members in this slide. So because the first member is x, so within the braces the first value will be assigned to the first member x. So the order of the value should be the order of the same as the order of the members. This is the important point. But if you don't want to follow that order of the member declaration, then you can use designated initialization. What does it mean? That we are going to discuss through this slide. We have declared one structure named point. It has three members x, y and z. So in over here we are declaring a structure variable p1, and now if you want to initialize the structure member, either you can put three values within the braces. The first value will be assigned to the variable x, second to the variable z and y, and third to the variable z. But if you don't want to assign the values in that order, then here is the method that is called designated initialization. I want to assign 0 to the y member. So either you what you can do, you can put dot yr here. So that means that you want to assign this 0 to the y member of p1. And secondly, in second after the comma I have written dot z is equal to 1. So that means this will assign 1 to the third member of the structure, that is z member, and the third will assign 2 to the x member. So earlier we discussed in this slide that we just wrote the values within the parenthesis, and those values will be assigned to the members of the structure in order. But here we are not following the members order, and if you don't want to follow the members order, then you can put the dot operator, then name of the member to which you want to assign the value, after that the equal sign, and then the value. So this is called the designated initialization, where we use the member name while assigning the values to the members of the structure variable. Then comes how we can access the structure members. So I have uh, written one example for that. In this example, we have defined one structure named point. So we are defining this structure before the main. It's not mandatory to define the structure before main. Even you can define it inside the main. So we will discuss that also in the coming slides. So if you declare a structure before the main, that means that structure is basically a global structure and that can be used anywhere in the program. So its scope is entire program. If you define it inside the main, then that structure will become the local structure. Its scope will be limited to the main only. So inside the main, we are defining one structure variable. So this is the method that we discussed earlier as well. First you will write the keyword struct, then the name of the structure, that is point, then the variable p1, this is the variable, and the values that you want to assign to the structure member, those values should be in the braces. So we have put those values in the braces. So after that there must be a semicolon. So this will initialize, this statement will initialize x and y members of p1 structure variable to 6 and 14 respectively. So if you want to change the value of the x member of structure variable p1 from 6 to some other value, then this is the method you can use. I want to assign 20 to the x member of the structure. So you can access the x members like this. First you will put the structure variable name, that is x1, then the member operator, this is called dot operator or member operator, dot, and then the member of the structure to which you want to assign a new value. So this will assign 20 to the x member of the structure variable p1. Now if you print the p1 structure variable, then I can use this statement p1.x. Here I have used this in printf statement. So this will print the value of x member of the structure variable p1, because the latest value of x is 20. So 20 will get printed over here. So you will get x is equal to 20, and the value of p1.y is 14. So that will get printed. So that the result of this program will be x is equal to 20 comma y is equal to 14. So this will be the result of this program. Then I have shown one example over here. The example is to find the distance between 2 points. I have declared a structure named point over here. So in this example I am using a 2D point. So I have defined two members in this structure, the x and y. So within the main I am defining two structure variables p1 and p2, and d is a float type variable. Now this scanf statement will read the values of the first point, x and y coordinates of the first point, through this scanf statement. So how you can read the structure members through the keyboard? Again, as we discussed in the previous slide, when you access the structure members, you use dot operator. So first is p1 dot x. So as we discussed earlier, if you want to read the value of any variable, you have to pass the address of that variable to the scanf statement. So this ampersand will pass the address of x member, so p1.x and p1.y. So this statement will read the x and y member of the structure variable through the keyboard. So if I input 6 and 4, the two values, then this scanf statement will read those values into x and y members of the structure variable. So that I have shown over here. The second scanf statement will read two values into the x and y members of the structure variable p2. So suppose the values that I have keyed in through the keyboard are 3 and 8. So this statement will read those two values 3 and 8 and assign to x and y members of the structure variable p2, that as I have shown over here. Then if you want to find the difference between the 2 points, we know the formula. So this will find the p2.x minus p1.x square. So we are using the power function, pow function, to find x2 minus x1 raised to power 2. So p2.x, so p2.x is basically 3, p1.x is 6, so this will give you minus 3, raised to power 2 will give you 9, so this power function will give you 9, and the second power function is p2.y, this will give you 8, p1.y is 4, so 8 minus 4 is 4, so this power function will give you square of 4, that is 16, so 16 plus 9 is 25, and this square root function will find the square root of 25, that is 5, so the value of d will be 5 or 5.0, and the next line will print the distance between points is 5.000. This is all about today's class. Happy learning. If you have any doubt regarding the structure that we discussed in this video, you can leave your doubts in the comment section. Thank you.